acceleration upward. Let's just make it 2.0 meters per second squared. Okay? So it's a different gig. Same process. Okay? Determine T1 first. Okay? So we're taking it at this point, signal Y1, T1 minus FG10. And this time it's going to be M10 times A. So T1 equals M10 times A plus FG10 M10A plus M10G. Factor out the 10. Okay? You just plug in your values. Ethan, did you get it? Did you get the value? I'll get it. 118. And we're only good to 2 sig figs this time. Okay. Not bad, right? Got it accelerating. Can I erase this and we tackle now tension 2? You're good? Can I erase it?
Here we go, 2. Let's do this second. Okay, I'm going to string this out. Fy 2. Okay, so you're going to have minus FG10. Okay, plus T1 minus T1, just for the sake of doing that, minus FG, okay, M20 plus, and I could put the 2, or is it okay if I go 2 times T2 equals M total, the total mass. Are we good with that? So this time, yeah, you got to take into account for the total mass. This is gone again. So, and I'm just going to rewrite it so that you guys have this. T2 M total. So the total mass. Unfortunately, A is positive, it's going upward. If A was negative, it would be downward. Excuse me, going downward would be negative, yes?
Can you explain why to account for total mass?
Because now these two tensions, it is this mass that's pulling down on it.
That's what I thought.
Okay, yeah, you got it. All right, so let's, is it okay if I jump, I'm going to skip some steps and jump to T2, what it's equal? So T2 equals M total, A minus FG10 plus, excuse me, plus FG20 over M total. Yes, ma'am.
Where's the 2, T2?
And I gotta bring the 2 over here, times 2, thank you. Yeah, and then it's M2, and not, yeah, why did I put M total? No M total, forgive me. I'm on stage, I got the camera on me, I'm kinda, okay? So yeah, T goes below.
Cut that.
All right, let's plug in our values and see what the heck we're gonna get. So, M total, 20 plus 10, that's where I'm getting the 30 kilograms. 2 meters per second squared, that's the acceleration, plus, heck, I'm going to pull out the 9.8. I'm going to factor that out, and I'm also going to have 30 here. Kilograms. Okay, and divide by 2. Do you have the answer?
Yes.
What is it?
177.
What?
177.
Yeah, 177. And we're going to get to 2 sig figs.
But it's addition.
Yeah, but you still have the 2.0.
Yeah, the 2.0. Okay? So now you got the 2 forces. Whew. Guys feel good, huh? Not too bad? So if you have the 2 boxes laying down on a surface, so if you have 2 boxes on a surface like this, and you got a tension, could you guys do that? Yeah, and you just apply the friction. So I would like to go on to a hanging mass, 2 different angles. That's going to be a little more complex. Deck this out. You got a ceiling again. There's no motion. And there is a concept I want you guys to get in the end after this. In this case, theta 1 equals 30 degrees. Theta 2 equals, oh heck, I'm going to go with 45 degrees. We're good? You're going to have a mass hanging from here. And again, let's make it 10 kilograms just to make life a little simpler. So in this case, you are going to have 3 forces. or the three tensions. 1, 2, and 3. The cool thing is you can handle tension 3 immediately. So the sigma Fy3, you can find the tension for that one, poof, because that's just going to be T3 minus Fg equals 0 because there's no motion. And T3 equals Fg, which is going to be 10.0 kilograms, 9.800 meters per second squared, and 98.0. Not bad, right? Okay, so now here's how we're going to think. This is kind of like that one homework problem, but now we're taking into account a lot of things. So, we're going to put a coordinate plane. This is parallel to the ceiling. So this purple line is parallel to the ceiling. That's cool because that means theta 1 is now down here. And theta 2, they're both equal to these angles on both sides. Normally I tell you guys to find find the net force in the y direction, right? In this case, since it's a hanging mass, you would tackle the first one because you're going to do a substitution. And I'll explain that. Because you have two unknowns here. You have two unknowns. This one we found. But you have two unknowns, and that's going to cause a problem. So let's tackle first the x direction. So since this theta has the I going that way, this is going to be a negative cosine. So it's going to be negative T1, because that's the resultant. Okay, and these forces are going upward. They're going upward. Cosine theta 1. Now I look at this side, okay, plus T2 cosine theta 2. Is there an FG in this direction? No. That's what's sweet about that. Ah, there's a reason why I chose this. And since this isn't moving upward nor sideways, it's not moving sideways nor upward, it's equal to 0, the net force. I'm going to solve for T2. I can use this in a substitution for the y direction. I'll explain that in a second. So T2 equals T1 cosine theta 1 over cosine theta 2. So I move this over, so I move this one over and divide by cosine. Good? Well, now let's solve for the y direction. So sigma Fy. Oh, these are above. So it's all positive. So this is going to be T1 sine theta 1 plus, well, I'll do this one, T2 sine theta 2. Oh, Fg is negative. And since it's not moving up or down, sweetness. I still have two unknowns. Oh no, not anymore. I can substitute. I now know T2. I can substitute this in here. So I'm going to rewrite it. T1 sine theta 1 T1 cosine theta 1 cosine theta 2 times sin theta 2. Can I bring this over? Is that okay? Yes, no? Okay. Fg. Oh, don't you see it? Oh, this is exciting. Look. That's going to make life easy. Yeah, and you can factor out T1. So I'm going to do it. T1, parenthesis, sine theta 2, 1, cosine theta 1, tangent. See, these two are dividing, so tangent tan theta 2 equals FG. Oh, put another parenthesis here. I can now take this whole thing and put it under here, and I now know T1. Oh, yeah. So guess what? Is it all right if I put this over here? I'm going to write this over here. So now, T1, because we're going to plug in numbers, FG, sine theta 1, plus cosine. I got to be careful because I mess up with this. That's a 2. So I want to make sure I got theta 1, tan theta 2 here. Okay, so we have FG, 10.0 kilograms, 9.80 meters per second squared. Divide that all out. Oops. Okay. Sine 30, cosine 30, and tan 45. And does somebody have that answer? No?
That's 72 meters.
I'm gonna go more sig figs, but I'll box the least because I want to put this back up here. And so now, see, we have T3, we have T1. Now we can find T2 because we found T1. So I'm gonna put 71.7, right?
Right.
Newtons. But to the correct sig figs,
Wait, no, it is 71.7 because there's 3 sig figs and everything.
yeah, we have 3 sig figs on everything. So this is correct. Let's just use that. That'll be fine. Okay, so let's plug it in up here. 71.7 newtons, cosine 30 over cosine 45. Right? And that's going to finish the notes once we get this answer. You got it? 87 what? Thank you. 87.9 newtons. Again, you're not trying to remember this stuff. What you're going to do is you're going to take your vectors, you're going to put the components in and solve for everything bit by bit. It's like reading a book. You know, you read the first paragraph, the next paragraph, connect the dots, right? The same deal. Your first paragraph, your second paragraph. Oh, I got to go back to connect the dots. Okay? Are we good? You ready for in class? Oh, wait, one.
You were talking about like tension and like sliding the boxes?
Yeah,
How would that work? Can you give an example?
just the same as a box. You want an example?
Yeah.
I was going to only do 4 examples, but here we go. Let's do another
No one
one.
else wants it. No.
Does anybody else want, or I can tell her?
It was like the second motion. Yes.
You guys want to do one? Okay, I'll come up with something. Let's do it. Got these boxes on the ground. Our boxes are masses. Let's see, let's make this one 5.0 kilograms. You have a tension, oh, let's make mu kind of somewhat interesting. So we got a coefficient of friction 0.1. Okay, just because I want to make life a little easier for myself, I don't know why. 10 kilograms. And let's say we're pulling it this way, giving it a little tug. Okay, and this time we're giving it a tug, with an acceleration of 2.0 meters per second squared. Just because I want to make my life easy. Okay? What are you going to tackle first? You guys tell me. T1, yeah. Take that one first. We'll make that label at T2. So tackle T1 first. Okay, all right, T1, all right. So, let's sum our vector in the x direction for 1. So what's that? We're going to have friction this way. So we're going to have minus F friction. I'm going to call it 1 for now, because there's more to that, right? Plus T2 equals M1A.
Is it T1?
Oh, did I put T2? So, brain. T1. Thank you. All right. Wait. What do we need to solve for? What's friction equal to? Everybody's supposed to know the equation of friction.
UFN.
Thank you. Friction has the equation of mu Fn, which is basically equal to mu Fg. Okay? So we're going to have to do this for 5, for the 5 kilograms. So T1 equals M1A plus, okay, and I'm going to take this equation, so it's going to be mu Mg 1 G. I'm going to factor that guy out. So M1A plus mu G. So 5.0 kilograms and 2.0 meters per second squared plus 0.01 times 9.80 meters per second. Okay, did somebody plug that in already? No? So 5 times parentheses 2 times 0.01 times 9.8. And I got 0.98 newtons. Let's see. Let me double check. Oh, no, I did something wrong. I got it. Plus 10. 10.5. 10.5 newtons. Sig figs. 11 newtons. We're good? And now, can I tackle T2? Can I erase this? Can I erase this? I got a couple of knots, okay. So this is going to be totally different. Okay, so this is tension 2. So here's the deal. We have friction, force of friction 1. We have plus T1, minus T1. Oh, that happens again. Yes?
Why would the friction be 2?
Because this mass is exerting a certain amount of friction. It's going to have a different Fg. Okay? And now I go over here, minus friction 2, okay, plus T2 equals M total again, guys, times A. Sweet deal, this is gone. So notice that I'm stringing this as one line. Okay? Is it okay if I skip a couple steps and solve for T? Okay. So T2 equals M total A plus F friction 1 plus F friction 2. Okay. M total 15 kilograms, 2.0 meters per second squared. Friction, I'm gonna pull out 9.8. Is that okay? Or I'll just write it all out. So this is going to be 0.01 5 kilograms, 9.80 meters per second squared. Okay, plus 0.01 times 10 kilogram, 9.80 meters per second squared. We're good? You could have factored out a bunch of things in life would have been a little easier, okay? You could have factored out a bunch of stuff. I got 31.5. Anybody else got a different one?
31.47.
Yeah,
Two
I
sig
round.
figs is 30.
Yeah, I just went 5 newtons and then, yeah, sig figs. 32, right?
31.
31, yeah,
4,
31. 31 newtons. So sig figs, I'm just going to go to 31. Erase it. Done. Because we're not doing anything else with that number, so we're done. Are we good? Yay. Okay.